In college algebra today, we looked at solving polynomial and rational inequalities. So we have something that should look very similar to last semester, except for this greater than sign right here. That changes things. So we're actually going to treat it just like we did last semester. Write an equal sign, and we'll deal with the greater than at the very end. So I see an x squared and an x. I can't combine them, so I know I'm going to have to factor or use quadratic formula. And that means get everything to one side. So I'm going to move that 15 to the left side and then attempt to factor. So you can just jump right into factoring this polynomial, or you can use one of the tricks to factoring. Remember, if there's a front number, you multiply the front number times the last. And we're looking for factors of -30 that add to the middle number, which is a 1. So if you don't see that 1, I'm talking about the imaginary 1 right there in the middle of the thing. All right. Hopefully you came up with the two, 6 and -5. Those both add up to 1. That's a funny check mark. Okay. So you write your two numbers as a fraction, and you put the very front number from the original polynomial under that fraction as the denominator. So I'm going to take that 2, and I'm going to write it right here and right there. Reduce if you can. So I can reduce that to 3/1. This one I can't reduce, and we're done. You just need to know how to write it as a factor. The bottom number gets an x, so 2x minus 5. And this one would be x plus 3. So if you can do that if you can write this down without doing that trick over there on the left, then go for it. It's just trial and error. A lot of people can do it. It just depends on you. Some people like the method on the left. Some people like to do it in their head. All right, now I need to solve this thing. Set both equal to 0. And we get x equals -3 and x equals 5/2. So all of that, everything so far has been review. What we do, we look at the bottom line down there that I typed. Well, not the bottom, not number 2, but where it says make sure to test values. I need to put these on a number line and test values to the left, in between, and to the right. And that's going to tell me what my interval of values are that work for the inequality. So for example, we could test, let's change colors. We could test -4, 0, and 3. Some you can do in your head. If you can do all of them in your head, go for it. I'm going to test them up here top right. So I'm going to test -4. Be careful with that negative. I use parentheses. And we get, let's see, 16 times 2, that's 32, minus 4. I think that is obviously a true statement. Take it one more step, 28 is greater than 15. This is one of the solutions, that interval. Let's plug in 0 and test that interval. This one you can probably do in your head. hope so anyways. 0 is greater than 15. Does that make any sense? I don't think so. So let's cross out that interval. Let's test 3. And this one looks like it's going to check out. We have all positives. We get 9, we get 18. Yeah, this is going to check out. So that's another solution. We just got to write it formally. So all that means is x can be smaller than -3, or x can be bigger than 5/2. All right, let's try another one. And copy down this sentence if you haven't yet at the very top of the screen now. All right, same situation. I see another x squared and an x. I need to get everything to one side, but first I'm going to write it with an equal sign. And then I'm going to move everything over. And let's try and factor it. So I go front number times last. I need factors of that. And they got to add to the middle number, which is a 2. And factors of -4, we could do like -4 and 1, -2 and 2. None of them add to 2. So this is not factorable. Sorry, we wasted time there. We must use the quadratic formula. That's not any fun. Although some people tend to jump to doing this first, because it does always work. So our quadratic formula looks like this. So let's plug in the 4, 2, and -1 in those places. Careful with the negative b. So we have x equals -2 plus or minus 2 squared all over 2 times 4. And you see right away, I hope, why this wasn't factorable, because we get 20 under that radical. 20 is not a perfect square. That's why it wouldn't factor. There is a 4 in it. I could take a 4 out. If I take a 4 out, it becomes a 2, and a 5 is left inside. I could divide everything by 2. But I still need a concrete number to go with. So if I type in those 2 fractions there, remember the plus minus means we have 2 fractions. So square root of 5, make it negative, subtract 1, divide by 4, I get -0.8. Here, I'm going to type it in just to make sure I'm thinking right. Yeah, -0.8. If I treat that square root of 5 as positive and subtract 1 from it and divide by 4, I end up with 0.3, which doesn't look fun to work with, but actually it works out pretty nice. Because remember, I don't want to pick those numbers. I want to pick numbers next to them. So what if we try -1, 0, and 1? Those, we can do a lot of that math in our head. So when I test out -1, make sure you use a parenthesis for the negative. You don't want to mess up on that after all that work. we get 4. And that does not look like it makes any sense, so that is not a solution. Let's try 0. Hopefully you can do that one in your head. And this one looks like it works out. We get 0 less than 1. So that middle interval is a solution. Let's test out the last one. And we get something very weird. We get 4 is less than -1. That doesn't make sense. All right, so our final answer is -0.8 up to 0.3, that one interval. I'd be okay with you using those two numbers. I would prefer you use the fraction with radical form, so I would prefer you to write it like this. But to be honest, if you wrote down -0.8 up to 0.3, I would take that as well. So, hope that made sense. I will see y'all later.